So hang on. So in this talk, I'm going to give you an introduction to analytics. So it's quite high level. And if you have any questions, don't hesitate to interrupt me, because the biggest compliment you can give to a lecturer is asking questions, because that shows that you're really engaged in the lecture and fascinated by the topics. So I'm a professor of data science here at the Catholic University of Leuven. I'm also a lecturer at the University of Southampton. My research focuses on data science, so analysis of data, small data sets, big data sets. Predominantly, we focus on areas such as credit risk modeling. We've done quite a bit of work on credit risk modeling. Recently, also more and more on fraud analytics, because fraud is getting more and more a big problem to many big organizations. There's estimates that many organizations think about 5% of their annual revenue is lost because of fraud. So if you could reduce that amount using state-of-the-art analytics, that could have a significant impact on cost savings or profit. I also do quite a lot of work on customer lifetime value modeling. I've co-authored a book on that in case you would be interested. In case you'd like to connect with me, you can connect on LinkedIn. You can also connect on YouTube, Facebook, and Twitter on my data mining apps account. Or if you're interested, I also have an online learning platform. This is Blue Courses, right? It's an online learning platform. It features various types of courses on credit risk modeling, on machine learning essentials, on fraud analytics, customer lifetime value modeling, etc. And all of these courses are self-paced online learning courses. That means that if interested, you can register right now and you can start anytime you like. And if you register for the course, you get 1 year access to the course. Now I have some good news for you. I see how many are attending this. I think about around 20. If I can't see it, but I think around 20. And as a way of supporting Ukraine in these challenging times, I'm happy to give anyone that is interested a free license to any of my courses. Usually these courses cost about 250 to 100 euros. But if you're interested, just send me an email, say you attended this talk, and I will sign you up for free for any of these courses. For those of you who are really triggered by my presentation and are really interested to know more information about it, I would recommend Machine Learning Essential course, because that builds further upon the topics that I'm about to explain. But obviously, if you're interested in another course, please feel free to let me know. So if interested, drop me an email after this course. My email was on the slides, and if you don't find it anymore, you can ask Irina. She can give me, she can bring us into contact. Okay, here you can see some of the books that I've written. My biggest love in machine learning is credit risk modeling. I've done a lot of work on that. I've written about 3 different books on the topic. But I've also written books on fraud analytics, customer lifetime value modeling, model risk, and database management. All of these books can be found on Amazon in case you're interested, or in case you have any specific queries, you can always let me know. Okay, what is analytics all about? Well, if you look at many contemporary firms, you will see that many firms nowadays think about banks, think about online retailers, think about supermarkets, etc. They have gathered tons of data that reflects their customer behavior, right? So they've gathered transactional data. They know when a customer makes a purchase, in what store, what items are being purchased, what's the amount, the timing of the purchase, etc. So all of that creates a huge amount of data that can then be leveraged for various types of purposes. We can start analyzing this data, and we can start looking at, for example, if we think about a supermarket context, we can look at what products are frequently purchased together. Because if we know what products are frequently purchased together, we can use that information to make product bundles or to organize our shelves, the shelves in the supermarket. If we know that 2 products are frequently purchased together, we can use that to, for example, put the products in close proximity of one another so as to facilitate the customer experience. All of these patterns can be learned using mathematics. Analytics is essentially about using mathematics to understand what patterns reside in data. And the mathematical techniques originate from a variety of different types of disciplines. Statistics, think about regression, linear logistic regression. From operations research, I'm not sure whether you had a course of operations research, but in operations research, you have techniques like linear programming or quadratic programming, etc., which all offer techniques to analyze data. The techniques can also originate from artificial intelligence or deep learning. Think about generative large language models like OpenAI's ChatGPT or Meta's Llama, for example, with which we're currently experimenting. So there's a plethora of disciplines that offer various types of techniques that help us find patterns in data. And the patterns actually originate from the massive digitalization that took place during the previous decades. The emergence of big data storage platforms like data warehouses, data lakes, operational data stores, OLTP systems, online transaction processing systems, has allowed us to store all kinds of information about transactions customers make. Think about Amazon, for example. You all know Amazon. It's an online retailer that is offering all kinds of services that we're also extensively making use of. But Amazon knows exactly what book or item is being purchased on their website after having visited what web pages, when the book is being purchased, where the book needs to be shipped to, etc. So that creates a tremendous amount of information for Amazon to make sure that every time each of us logs on to Amazon, we get a website or we get an Amazon website which is tailored towards our interest, which is tailored towards our needs, which features the kinds of things that we're interested in. Now, this is all nicely automated using analytics, using data science or machine learning. And do note that the terms analytics, machine learning, or data science are often used interchangeably. And the whole idea of analytics is to get those deep insights in the data, to know what patterns are in there. If a customer buys product A, is he or she also likely to buy product B? Not only this, but also detect, for example, patterns of fraudulent behavior, because every organization is exposed to fraud. Remember the estimate I gave earlier, where according to the OECD, which is a European organization, about 5% of the revenue of every organization is lost because of fraud. So using analytics, we can see what types of fraud patterns are available in our data. Because if you understand fraud, then you can start fighting it using adequate fraud prevention tools. But obviously, this is quite a big of a challenge because human behavior is quite complex. Our behavior depends upon our preferences, depends upon our environment, and moreover, our behavior continuously changes. What interested me like a year ago is no longer the same as what interests me nowadays. For example, personally, I'm very fascinated by history. Also, your history, for example, which I don't know a lot about, but I'm very interested in the history of Ukraine and the various ethnic populations there, and how in history the various the political regimes and the various religions that took place in Ukraine, etc. I don't know a lot about it, but it interests me. So every now and then I listen to podcasts relating to this to maybe to understand some of the current situation there. So all of that reflects upon my human behavior and it's subject to change. And it's very important for analytics to understand this complex human behavior, look at the dynamics, and try to model this in a mathematical formula. Because that's what analytics boils down to at the end of the day. It's a mathematical formula. And there's many algorithms that have been developed since the 90s of the previous century to help us tailor this, to help us understand this. And do note that this is not a man versus machine fight in the sense that the machine is, we often refer to analytics as well as machine learning. It means that you use algorithms to understand human behavior. And the emergence of large language models like ChatGPT, Llama, etc., to some of us poses a threat to human jobs, right? So they think AI will overtake human jobs. I'm not a believer of that personally. I think AI will create new types of jobs. So it's not a man versus machine fight, it's a man and machine fight. Both are complements to one another. Humans and AI should closely work together in order to make the world a better and more sustainable place. And I believe new developments in AI will largely contribute to this. If you think about the whole area of large language models like ChatGPT, as I already referred to quite a number of times, it will create all kinds of new job opportunities, like prompt engineers, for example, how to intelligently collaborate with these large language models and make sure that you can use them for competitive advantage. Okay, so let's have a look at some analytics examples. And we already spoke about beer. It's a bit early in the morning, and don't worry, I don't have an alcohol problem, but I mean, I like drinking a beer in the evening. So here you can see three examples of what you can do with analytics, right? Leuven is known for its pubs, right? So we have lots of exciting pubs in Leuven. And with analytics, I can understand how customers like to have a beer, what types of beer they want, and if they like beer A, they are most likely to also like beer B. And at the end of the day, as a retailer, as a pub owner, what you want to do is you want to make profit, right? So you want to make sure that you sell good products with a sufficient profit margin. Using analytics, you can do, for example, upselling. So if I would go to a pub right here in Leuven this evening, and I would order a Stella Artois. This is a beer which is brewed literally right across the road from here, right? This is where the brewery is located, and they're producing tons of Stella Artois bottles each day. As I say, if I would open my window right now, I could smell the yeast of the brewing process. If I go to a pub and I order a Stella Artois, this is the #1 lager beer that you would order in Belgium. What if the waiter would recommend a more upscale beer like a Westmalle? It's a very good beer. It's an Abbey beer. It's a Trappist beer. A Trappist beer means that these are beers that are being brewed by monks according to old medieval recipes. And part of the revenue goes to social welfare. It means that by buying this Westmalle beer, you're actually helping out some of the poorer, less fortunate people. Now, the waiter could try and convince me to purchase to buy this more expensive beer instead. That's upselling. You're trying to sell more of the same item steered by analytics. This is a simplified example, but actually you can understand or model customer behavior using analytics and understand what types of more expensive and more profit generating products I can sell to my customers. So instead of Stella Artois recommending a Westmalle, it's a kind of upselling. Cross-selling means that you noted that two products are often purchased together. And you know that if a customer buys one product, maybe he or she is also interested in another product. So imagine that the waiter convinced me, instead of Stella Artois, to go for Westmalle. So, okay, I'm buying Westmalle. What the waiter can then recommend and say, Bart, if you want Westmalle, if you want to have a really tasty experience, why not combine it with some well-known Belgian Abbey cheese? Cheese goes really well with beer here in Belgium, and it's a very nice food pairing. It's a combo. And that's something that we can determine using analytics, right? We can see what products often are purchased together and as such offer product combos. That's cross-selling. Obviously, the evening may go down very smoothly, and if you ask me, maybe a bit too smoothly. And once I had too many beers, it may no longer be good for me. And the waiter may at a certain moment decide to stop selling me beers because, I mean, it's not too good for me anymore. That's an example of downselling. Sometimes you want to discourage customers from buying products to make sure that they have a good customer experience, right? These are three types of applications of analytics that I have illustrated with a very simple example that can be very nicely supported using analytics. But we can go a lot more sophisticated than that. You can also do credit scoring, for example. And in credit scoring, every bank in the world, and after my PhD, I traveled around the world teaching banks how to do credit scoring. So if you go to a bank in Ukraine, for example, and you apply for a loan, you want to buy a car and you need a loan, you want to buy a house and you need a mortgage, or you want to do some traveling and you need to borrow some money, then obviously you will not get a loan for free, right? The bank will charge you an interest fee, and it will also screen you. It will look at who are you, right? When were you born? Are you employed? Do you have an income? Yes or no? Do you own some real estate property? Do you have a savings account? How much money is on your savings account? And so on. And it will build a credit scorecard, which you see right here. To the right, you see a credit scorecard that has 4 age categories, 2 gender categories, and 5 salary categories, which have all been defined in a particular way, and to which points are assigned. And the agreement is the more points, the better the credit worthiness of that customer, right? And this scorecard has been built using analytics, right? I don't have time to explain how the scorecard has been built, but the scorecard is an example of an analytical model. It's an example of a pattern that has been learned from data. For example, on my Blue Courses platform, I have a course of about 6 hours that teaches you how to build this kind of scorecard, right? But that's an analytical model. And once you have this analytical model, once you have this mathematical model, you can use it to facilitate your decision making. If a new customer, Bart, applies for credit, and Bart's age is, well, unfortunately, I'm not 32 anymore, but not too much older. If my age would say it's 32, then I can look up the points. This is here, 32. It's between 26 and 35. It's 120 points. Well, my gender is not female. It's male. But anyway, let's say that the person that applies is female. You get 180 points. The salary is $1,150. That's right here in this band. So I add up all the points, and then you get 460 points. 460 points is the overall measure of credit worthiness of this particular customer, which you then need to compare against the threshold, against the minimum required credit quality. And let's say that this threshold is 500. Well, 460 does not reach that threshold. It's below the 500, so you're going to refuse credit. This is an example of analytics in working, right? And that's how financial institutions, lenders worldwide automate their credit risk modeling using analytics, right? And if you're fascinated with that, you can sign up for one of my Blue courses. As I said, as a token of support to you guys, you can get a free license if you're interested. Just send me an email and let me know what course you're interested in. Fraud is also very important, and fraud is typically something that is tackled using if-then rules, right? Rules that are being learned from data using various types of analytical techniques, like decision trees are one of them. And I won't say too much about them because I only have 50 minutes. But decision trees allow you to analytically extract knowledge from data, reflecting upon the fraud patterns that are in the data. And they could learn all kinds of business rules that tell you when fraud is in the data. And for example, we do a lot of work in insurance fraud to detect insurance fraud claims. Lots of people, well, not lots of people, but some people file fraudulent insurance claims. They try to cheat upon their insurance provider to make sure that they get some money back from the insurance provider, whereas in real life, they're not entitled to do so. So they do so in a very fraudulent way. And we can learn this fraud behavior using analytics. And here you can see an example of a rule. If the amount of the claim is above a certain threshold, and let's say it's a car insurance example and an accident took place with the car, and if there's a severe injury because of the car accident, but no doctor report, then that is suspicious because there's a severe injury. The person got severely injured, but no doctor came to the scene. That's suspicious. And if the claimant has multiple versions of the accident, then that even further raises the suspicion. Then we will flag the claim as suspicious. That's a pattern that we can learn using an analytical technique, which we refer to as decision trees. Recommender systems. Here you can see if you go to Amazon, for example, and you look at one of my books, and here you can see one of my books, Principles of Database Management. This is a book that I use in my course, Principles of Database Management. And my lectures of this course are also publicly available for free on YouTube. So if you're interested to learn about database management, I'm more than happy to give you the link where you can find my lectures. They're available for free. So I'm an academic, right? So I'm not in it for the money. I'm in it for, I like knowledge dissemination and I like doing research. So Amazon is gonna build what we call a recommender system. It's gonna look at if somebody buys Bart's book right here, what other books is he or she likely to buy, and as such offer product bundles. You can see that if somebody buys this book, they're likely to buy 2 other books of mine. Here's one on practical web scraping. Here's one on fraud analytics. And the one in the middle is not a book that I have co-authored. It's a book that somebody else has co-authored. But obviously, Amazon tells you that this is also a book that is of interest to those people. Okay. So, and this is what we call customer journey analysis. This is another type of what we later on would call descriptive analytics, where you understand how customers convert, how customers make a purchase. What are the steps before a customer decides to make a purchase, yes or no? Maybe he or she clicked a Facebook ad, then visited your website, and let's say it's a website of a bank. Then he or she simulated a mortgage because the customer just bought a house and needs a mortgage. Then he or she makes a phone call to your bank or sends an email, fills in a loan application, then a credit scoring takes place, which is what we just illustrated, and then a decision is made whether a loan will be offered, yes or no. That's the customer journey that a customer will typically go through as he or she tries to buy a loan from your firm. Text analytics is also something that is very important, especially with ChatGPT and all the large language models that are currently being developed. I'm not going to say too much about that, but here it refers a lot to about query and answering, as ChatGPT does. Text retrieval, which is also what ChatGPT does. It's trained on a large corpus of text, and it tries to retrieve answers to your text queries based upon text similarities. Text classification is something together with a colleague researcher that we have been working on quite extensively recently as well, using techniques like deep learning. I'm not going to talk too much about deep learning in this setting. I would like to continue and look at the various steps that you typically run through as you're doing an analytics project. So if you do an analytics project, the first thing that you have to do is you have to identify the business problem. What is the business problem you try to solve using analytics? The business problem could be fraud. Maybe you want to tackle fraud. You want to look at all the data that you have available and identify fraud patterns. Another business problem could be credit scoring. You want to distinguish good payers from bad payers. Another business problem could be churn prediction. Churn prediction, I don't know whether you're familiar with the English word churn, but I'm going to explain it to you. Churn prediction is something that is very important in telco, in telecommunications. For example, I have my iPhone right here, and I'm with a Belgian telco provider. If I would be dissatisfied with that Belgian telco provider because it's too expensive, because it's bad coverage, because it's very expensive roaming agreements, because the customer service desk is not to my standards, to my liking, then obviously I can decide and leave from telco provider A to telco provider B. If I do that, I'm a churner. It means that I'm no longer at telco provider A, I'm churning for telco provider B. If you're telco provider A, you don't want customers to lose. So you can try and detect what are my customers that are most likely to churn or which I am most likely to lose soon because they're dissatisfied with my service. And you want to prevent them from churning because you want to keep them. That could be your business problem. Once you have properly identified your business problem, fraud, credit, or churn, you identify the data. And the more data you can identify, the better, because data will give you all kinds of opportunities to find interesting patterns as to why customers are fraudsters, as to why customers churn, as to why customers are bad payers. The more data you have, socio-demographic data, transactional data, payment data, marketing data, external data, data about the macroeconomy, etc. All of that data could reveal interesting insights into the customer behavior. So you bring it together and you select it and you bring it into a staging area. That means that you provide a comprehensive overall consolidated view of the data right here, right? That could be into a database, into a data warehouse, into an operational data store or a data lake, as we often refer to that. And once it's in there, once you have this consolidated view, you have to clean it because some data may contain inconsistencies, like age is missing, or somebody's income is minus 1 million euros. That's a data error. So data can be very erroneous. There could be errors in there that you have to clean. So that's something that you have to do during data pre-processing together with transforming the data. Transforming the data means that you're going to enrich the data. So based upon date of birth, you will derive the age of the customer. So all of this is data pre-processing, and then you're going to analyze it using analytics or machine learning or artificial intelligence. And the distinction between all these different disciplines is actually very blurred. And what you want to do is you want to distinguish the two red dots, which the two red dots represent the tuners, the frosters, the bad payers, from the green dots, which represent the non-tuners, the good payers, the non-frosters, etc. And you want to find those patterns like the scorecard that I referred to earlier on, or the if-then-else rules that I referred earlier on, such that you can use them in your business setting to automate credit risk modeling, to detect fraudsters, to develop fraud prevention strategies, and so on. So that's the entire analytics process model. And when you do analytics, there's two types of analytics that you can think of. There's unsupervised analytics and there's supervised analytics. And let me clarify that into some more detail. Assume that you have data available about your customers and just try to picture the data in an Excel file, Microsoft Excel. Microsoft Excel has rows and columns. In the rows, you have customers. So you have customer Bart, you have customer Victor, you have customer Anne, you have customer Laura, you have customer David. So you have every customer in the rows. In the columns, you have variables. You have variable like Bart's gender, Bart's age, Bart's income, Bart's address, Bart's marital status, etc. All of these variables feature in the columns. Now, if you do supervised analytics, which is my second bullet right here, then it means that there's one column that serves as your target. If one of those columns indicate that Bart is a fraudster, yes or no, that David is a fraudster, yes or no, that Laura is a fraudster, yes or no, or that Bart is a bad payer or a good payer or a churner, yes or no. If one of those columns is something that you're aiming for, you want to discriminate between the churners and the non-churners, the fraudsters and the non-fraudsters. So if one of those columns prominently stands out as a target that you wish to predict, then you have what we call predictive analytics or supervised analytics, because you have a target variable that you're trying to predict. And that target variable could be categorical, like churn, yes, no, fraud, yes, no, bad customer, yes, no, but it could also be a continuous variable. Maybe you want to predict Bart's income. Maybe you want to predict Bart's debt level, etc. That could also be continuous. Maybe you want to predict sales of a particular type of store, etc. So if you have a target variable available, then you have supervised or predictive analytics. If you do not have a target variable available, then you have unsupervised or descriptive analytics. That means that all the columns have the same word in terms of doing analytics. And maybe you want to do some customer segmentation. You want to find clusters of customers which are very similar. But in unsupervised analytics, you do not have a target variable available, right? That's the idea. Let's have a look at supervised analytics. Here you can see supervised analytics because here you have various types of customer ideas: Bart, Victor, Sophie, Laura, their age, their income, their marital status, some kind of credit bureau score, and this is the class. This is the target variable available, good, bad. And using all this information, age, income, marital status, credit bureau score, you want to analyze that information using mathematics to predict whether the class is good or bad. So you want to develop like the scorecard or a mathematical model to predict that. And obviously you will see that you have to do some data pre-processing, because as you brought your data together, you have missing values. You have question marks right here, right there, right there, right there. And you also have what we call outliers. And outliers are extreme observations, which shouldn't be there, but yet are there because of data inconsistencies, because of data errors. So here you can see an exceptionally high income. This is someone with exceptionally high income. Why is this? This is probably a data error. Let's hope not for the person, and the person really earns that much money, but most likely this might be an outlier. You can see also an outlier for credit bureau score. Outliers could get into your data because of data entry errors, etc. This is an example of predictive analytics, where you have to do some data pre-processing first, get rid of the question marks, the outliers, and then try to predict this. Here you can see an example of, again, predictive analytics, but where your target variable is continuous. CLV stands for customer lifetime value. This is, again, an Excel sheet. Customer 1, Bart, Sophie, Victor, Laura, their age, how long ago since they made a purchase. This is the recency variable. How frequently do they purchase on average on a monthly basis? The first customer on average buys 4.2 products a month. And what's the average monetary value of the purchase? And then you can see the CLV. What we now like to do is we like to predict the customer lifetime value, the value that the customer is going to generate during the upcoming time period, using a linear regression model, which you can see at the bottom of my slide. For example, here you can see a linear regression model. That's an analytical model. It's neat, it's simple, it's clean, because it's linear regression, and that's something that you try to estimate from data. Very nice example of linear regression, right? How to do that, I will not clarify in this course. Irina asked me to just give a brief introduction to analytics, but if you want more information about that, I can definitely give it to you. This is supervised analytics, supervised learning, predictive analytics. Sometimes your target variable can also be categorical. Here it is continuous, right? So it's between 0 and whatever, 10,000 or hopefully more. But it can also be categorical, as we said earlier on, right? So here you have John, Sarah, Sophie, age, income, gender, and here it's categorical. So an extension of linear regression has been developed that is particularly tailored to categorical variables. I see that there are 2 questions in the chat. I think I will tackle those at the end of the talk, but I will answer your questions. Don't worry. So the good, bad target variable right here is your target that you wish to predict using all this information. And an extension of linear regression has been developed, which is called logistic regression. And this is one of the most popular examples of analytical models. And basically what it does is it estimates the probability that a customer is good, is a non-tuner, is not a fraudster, is a good payer, and so on, given all kinds of variables like age, income, gender that you see right here. And basically what it does is it takes the linear combination of each of those variables and it puts that into this nonlinear transform, 1 divided by 1 plus e to the power minus the combination thereof. And the reason it puts that into that nonlinear, maybe a bit of a complex transformation at first sight, is because the outcome of this transformation, no matter what value for age, income, or gender you put in, the outcome of this 1 divided by 1 plus e to the power minus z transformation is always bounded between 0 and 1. And if it's bounded between 0 and 1, then we can interpret it as a probability. Then what comes out is between 0 and 1 and can be interpreted as a probability, right? That's logistic regression. It's one of the most popular analytical techniques used by companies nowadays. And in essence, it's linear regression with a transformation on top of that to squeeze the outcome between 0 and 1 such that it can be interpreted as a probability. If you look at the big international banks like HSBC, Bank of America, Bank of China, etc., they all use this kind of variant of linear regression called logistic regression in their credit scoring models. Irina, I have to stop at 20 past the hour, right? Which gives me about 10 more minutes. Is that correct?
So I will check the time. It seems to me about, yes, 12 minutes.
12 minutes. Okay, I will
Yeah.
stop at 20 past the hour, and then we have maybe we have some time for questions. I will tackle all the questions. So
Perfect.
then we have obviously commercial software. In our research, we do a lot of Python. Sounds a bit poisonous, but it's really not as difficult as it sounds. But we have historical data that we have available. We import that in Python, and then we build those kind of regression models that help us decide for future loan applicants whether they're credit worthy, yes or no. So there exists, Python is a programming language and have all kinds of built-in functions, we refer to them, that allows us to make these decisions. This is what we call supervised learning. And another very popular technique is decision trees. This is a decision tree, just like I can learn a linear or logistic regression from that tabular data set, I can also learn a decision tree from tabular data. How to do that, I cannot comment in 10 minutes because there's some other things that I would like to briefly highlight. But a decision tree is a structure like this. If income is bigger than $50,000, yes, we need to verify whether age is less than 40, yes or no. If yes, the customer is a good payer, otherwise it's a bad payer. This is a decision tree that has been learned from historical data. It's an analytical model, which means every analytical model is imperfect. It learns stochastic, probabilistic patterns from the data. So that means it will not always be right. But if it's more right than a random model, then it makes sense to use it, right? And these decision trees can be very easily in Python learned from historical data using using all kinds of routines and software functions which are available in Python. Neural networks, I will not comment on that, but I have a slide in case you're interested. Neural networks, and especially also deep learning neural networks, in a nutshell, there are multiple logistic regressions combined together. Earlier on, we saw logistic regression. In a neural network, instead of one logistic regression, you're going to have hundreds of them. Hundreds of logistic regressions, hundreds of regression models that combine together, and as such allow to squeeze more complex patterns out of your data in order to predict your target, right? So you can see a deep learning neural network, which is many hundreds of these logistic regressions all connected. One output feeds as an input into the next layer, etc. For example, a current pet project that I'm working on a project with the National Museum of the Royal Navy, which is the sea force of the United Kingdom, located in Portsmouth, which we recently visited. And we got a unique collection of black and white images. You can see an aircraft carrier right here. You can see a battle cruiser. You can see a submarine right here and a destroyer right here. And we try to understand the patterns which are in these images such that we can automatically classify their entire digital collection in terms of this image is a cruiser, this image is a battleship, this image is a submarine, and so on. This is something that I'm working on right now. Descriptive analytics or unsupervised learning means that we don't have this target variable available. So we don't have this column that allows us to say somebody's a good customer, a bad customer, or we don't have this target column available that tells us the customer lifetime value. And yet, even if you don't have this target variable available, if you have no target variable available, you can just look at patterns in the data. One pattern is clustering. I can look at what customers are similar or homogeneous in terms of their behavior, in terms of their transactional characteristics. So I can cluster customers. I can look at, I have two types of variables like recency, how long ago since a customer made a purchase, frequency, how frequently is a customer purchasing, and then try to find clusters in there. That's an example of unsupervised learning or also descriptive analytics. And if you have a cluster that is very distant from the other clusters of the data, so here you can see I have three observations that are very distant from the other parts of the data, then these could be, maybe there are anomalies, fraudsters that require closer inspection. So clustering means that we find homogeneous subgroups of transactions, of people, of customers in our data set. Association rules try to detect frequently occurring patterns between items. So here you can see 10 supermarket purchases. Let's say you go to a supermarket and in transaction 1, Bart buys beer, milk, diapers for his kid, and baby food. Luckily, I don't have to purchase diapers for my kids anymore. Transaction 2, another person, Sophie, buys Coke, beer, and diapers. Person 3, Victor, buys cigarettes, diapers, baby food. Person 4, Laura, buys chocolate, diapers, milk, and apples. So there's lots of people that purchase stuff in their market baskets. What you can then do is you can find what products are often purchased together. Because if I can find what products are often purchased together, then I can use that, for example, to develop product bundles or to put the products in the supermarket physically closer to one another so as to facilitate the customer experience, right? So if you frequently buy beer and diapers, let's say, then you want to put them next to one another. May sound like a funny example, buying beer and diapers, but it's a textbook example which is often used because apparently there was an American supermarket a long time ago that found that for some reason on Friday evenings, beer and diapers were frequently purchased together. So we can try to find those patterns and we can look at, for example, an item set, what items are frequently purchased together in a set, see how often that item set applies to the data. So I can see that this item set out of the 10 transactions, 3 transactions, which are the red transactions denoted in red, have baby food, diapers, and beer. So the support for that item set is 3 out of 10. And based upon that item set, I can then come up with an association rule. There's plenty of association rules that I can come up with, but one of them is if you buy baby food and diapers, then you buy beer. That's one association rule. I can also say if you buy baby food and beer, then you buy diapers. And then I can look at the conditional probability. For the ones that bought baby food and diapers, well, this is here, baby food and diapers, baby food and diapers, baby food and diapers, baby food and diapers, baby food and diapers. There's 5 that bought baby food and diapers, 3 of which also included beer. So this association rule is not perfect. It's not always the case that if you buy baby food and diapers that you're gonna buy beer, but in 60% of the cases, this purchase takes place, which is very interesting information. It's these kind of techniques, and I can elaborate more on that because this is just a high-level overview of analytics that are being used by Amazon to look at what books are frequently purchased together. We can then also look at the time when those purchases take place and look at, but I'm not going to say too much about that, at sequence rules, like because an association rule is like a cross-sectional data set, but I can also look at the time, like a person first buys product A, then product B, then product C, or I can also look at the time. It doesn't have to be product purchases. It could also be website visits. Like a customer on your website is first going to visit page A, then page B, then page D, then page K, and so on, because that will allow us to unravel customer journeys and see how customers navigate our website before they start making a purchase, for example. That's sequence rules, right? I'm going to conclude because I only have a few minutes left. We do a lot of research on analytics, and if you want to validate an analytical model, we have to look at the statistical performance, to what extent it actually captures patterns that are in the data. And there's quite a lot of statistical performance measures that have been developed. Analytical models also have to be interpretable. They cannot be too complex. If the mathematics is too complex, then businesses will be very reluctant to use them. They will not be willing to use them because it's too complex. They have to be operationally efficient. You have to be able to run them fast. They have to be profitable at the end of the day. So we've done a lot of work on profitability of analytical models. They need to have a low ecological footprint. This is especially important with modern day deep learning models, which often have trillions of parameters, causing a very heavy carbon footprint, which can be measured in terms of CO2 emission, for example. And then privacy and ethics is also very important because there's more and more data available. So we also have to take care of this. I want to conclude by saying that analytics, if you look at analytical model risk is also a very relevant issue. And here I conclude with a statement from George Box, which has a lot of contributions in statistics, and who said all models are wrong, but some are useful. And this also applies to analytical models. It's not that because we get a pattern from data that it's always valid. Right? If it's in a majority of cases valid, then obviously we can start using it. If it's better than a random pattern, then it may give us the competitive edge or advantage that we're looking for. But it's never a perfect pattern. And that has been a topic of a recent book that I've written on managing model risk, which is available on Amazon. And actually, we're going to come up with a new version of this book. We're currently working on a new version of this book, but we need 1 year to complete it because the emergence of large language models like ChatGPT creates all kinds of new issues in terms of model risk that we have to, we have to immerse ourselves into some of the newer literature and challenges in there in order to update this book. I see this is the end of my presentation. So in this presentation, I wanted to give you a brief overview of analytics. We spoke about various types of analytical applications like credit scoring, fraud detection, recommender systems, cross-selling, x-selling, upselling, downselling. We distinguished predictive or supervised learning from descriptive or unsupervised learning, depending upon whether you had a target, a variable available, yes or no. We briefly touched upon linear regression, logistic regression, decision trees, clustering, association rules, sequence rules, and then we finished off with the very important topic of model risk. And that brings me exactly to 20 past the hour. I see there are some messages in the chat, so I will open the chat right now and see some very question at the end of the class. CLV is customer lifetime value. Thank you, Irina. So Timur, thank you for a question. Does there exist a scheme for choosing corresponding machine learning algorithm for tasks? Yes, thank you. Very good question, Timur. K-means is a clustering technique, right? So it's a non-hierarchical clustering technique. When you want to cluster data, when you want to find subsegments in your data, then K-means is a very good clustering technique. There exist some other ones as well, but if you want to start off, if you want to do unsupervised learning and you want to cluster, then K-means is a very good clustering technique. Naive Bayes and decision trees are techniques that can be used for supervised learning. Naive Bayes is a type of Bayesian network where you look at conditional dependencies between nodes in a network. And typically it's a very good technique, but it typically assumes that you have a target variable available. So you can use Naive Bayes has been used a lot for text classification, for spam filtering to see whether a message is spam, yes or no. It can be used for credit scoring, just like decision trees. Decision trees are actually very popular techniques for credit scoring and churn prediction. So yes, there exists a scheme. There exists, well, not a scheme, but there exist clear guidelines or recommendations about when to use what technique. Anyone else has some questions? And feel free to ask me any question, right? So it's always nice to have questions.
Arsen, you're welcome.
If you are talking about points, it can be different mentality, and a person with, for example, 2,000 salary will give you less than with 1,000 salary, because we are people. One person goes to pub after work and another wants to drink because of breaking up with girl or boyfriend. It can depend on moods. How we recommend this? How can we
Yes, the idea is the more information, I understand your general point, the more information you gather, the better about your customer, right? So if you have to have a complete picture, as complete a picture as possible about your customer, it will never be complete, right? Customer behavior is also irrational, right? I can have the same characteristics as you, same age, same time of work, same type of civil status, etc. Yet my behavior is different than yours for whatever reason, because there's variables that are not captured in the data. The idea there in analytics is the more data, the better. And we always say, let the data speak. That means the more data, the better. And if you then analyze the data using analytics, it will try to detect the best pattern possible given the data that has been offered to the analytical technique in order to be estimated. But it will never be perfect. But talking about your particular example, if you can get some proxy variables that could actually measure the particular mood of a customer, that could help you to understand a customer a lot better and tailor your product offerings better to his or her needs.
Thank you. And another question, which forms you recommend for gathering information? How can we do this?
What are you talking about, software?
Talking about
software. Depends upon whether you have structured or unstructured information. Structured information, that means tabular information. It means you can in rows you can represent it in rows and columns. Obviously, there exist database techniques like relational databases, which are very tailored to storing structured information. If you have unstructured information like text documents, images, videos, audios, you have to look at other types of storage platforms which are particularly suited for this, like for text documents or graph-based data, like call networks, for example. There exist no SQL databases, something a bit more technical, but if you're interested in more information, then I can definitely give that to you, which are particularly tailored to storing this type of unstructured information. But the global goal in analytics is to start off with as much information as possible, bring it into a staging area that could be a data warehouse, a data mart. Sometimes it's also a data lake. A data lake is a massive dumping place that allows you to store both structured and unstructured information at the same time, and then use that subsequently for analytics.
Yeah, I mean, how can we ask questions with our customer?
How can we ask questions with our customer?
Maybe we are owner of a pub, and how can we do this research?
Well,
maybe you're asking a marketing question, Arsen, if I'm not mistaken.
If you're owner of a pub, obviously when you sell a beer, you're not gonna ask to the pub visitor what's your age, what's your marital status, the only thing that you can, the information that you get if you want to.
Yes, students, can you hear, Bart?
No.
No. Some interruption. Так, ну тоді зачекаємо зараз. Я напишу йому в WhatsApp.
Progress.
Irina, you're on mute.
I do know because I'm calling, yeah. Now Professor Bessens will join by iPhone. Я зателефонувала, просто вона запитала щось з інтернетом. До речі, він в Україні краще, ніж...
Can you hear me now?
Yes, we can.
Okay. You cannot see me, but you can hear me because, but that's important. So, yeah, sorry, I just got disconnected. I don't know what happened. All of a sudden, my internet dropped out. So now I'm on 4G. But anyway, the answer to your question is that it's really important to gather all the information you have. And sometimes there are situations where you don't have all the information available, but based upon what you have available, if you're an online retailer, you know where customers come from, the timing, you know what page they have seen before, typically you know what products they have, purchased before, if they have purchased any products before. And then based upon all that information, and the more you have available, the better you can tailor your next product to that particular type of customer. Make sense?
Thank you very much, Bart. Because we have time limits, maybe last question about the recommended literature, if possible now or later. What is your recommendation for the book in the chat of courses for ML developer?
So you're talking about recommended literature on the topic of this lecture. Is that your question, Irina?
Yes, particularly.
Okay, yeah. So I can refer to one of my own books. I have a book, Analytics in a Big Data World, which actually takes this lecture as a starting point and goes into a lot more detail about the various techniques like linear, logistic regression, also k-means clustering, naive Bayes that were asked in one of the questions. So I can recommend my own book. There are also other books available on the internet that discuss the topic. But obviously, when you pick a book, it's always very important to make sure, I don't know what your background is, but some students are more mathematically oriented. They want to know the nitty-gritty details of all the mathematical details, whereas other ones focus more on the applications. I can tell that my book tries to strike a balance in between offering enough mathematical detail without getting inundated in it, and focusing on the business and practical applications thereof. So I could recommend my book, Analytics in a Big Data World, which you can find on Amazon if interested.
Thank you very much, Bart. It is completely not possible to switch on the camera for making a group picture.
Yes, I will try and do that, but I will hang on. I don't know what happened here in my email.
Dear students, could you please switch on your cameras to make a nice group picture?
Do you have 1 minute, Irina? Then I will.
Yes, we do have now. We are switching on, and
I will quickly shut down my computer and I'll switch it on again. And I have
okay,
to. It's really weird. Sorry.
Yeah, it happens. And
yeah, it's really weird. Privacy, installing a privacy camera. I have to go to installing privacy camera.
Not many students.
Privacy camera.
So please switch on your cameras. Who can do this? And maybe better to switch off the demonstration of the screen as well, but I'm not sure we can do this. Okay.
Here you go.
Keep smile, yeah. And picture number 1. Okay. And I think so, dear students, I can see now whom, Ola, Simor. Yeah, let's do the second one for the second group. Okay. Perfect. And yes, probably last one.
Yeah, I'll go ahead.
Okay, thank you very much, dear Bart, for your
Thank you very much.
very interesting lecture.
Thank you very much.
Yes,
Pleasure talking to you guys. Take care, okay? Take good care. It was a great honor to present for you guys.
Thank you. Have a good day. Goodbye.
Have a good day. Bye-bye. Take care. Bye.
Thank you.
Thank you. Dear students, we can go for a break. Йдемо на перерву і зустрічаємося за 10 хвилин. Добре?
Okay.
Так.